out here in the vast icy void far beyond the sun's reach, where worlds should be locked in eternal frost, NASA's most daring probe has uncovered a hellish fury, unlike anything imagined. Images streaming back from the edge of the Jupiter system reveal colossal volcanic explosions, tearing through the surface of a moon called Io. Eruptions so immense, so powerfully radiant, that they mark the most extreme outbreak of volcanism ever witnessed anywhere in our solar system. This is not some distant inferno on a forgotten world. This is Jupiter's closest large moon, a place of relentless fire raging against the cosmic cold. Driven by forces so profound, they reshape everything we thought we knew about planetary fury. The realm around Jupiter teems with moons, nearly 100 now charted, with more emerging as our instruments peer deeper into the shadows. Most are tiny, fragile worlds of ice and dust, but 4 stand apart, colossal orbs discovered centuries ago through one of humanity's first telescopes. These are the Galilean moons, eternal companions locked in a gravitational dance with the giant planet. Farthest out lie Ganymede and Callisto, immense spheres of ice over rock, their surfaces scarred by ancient craters in a silent testament to billions of years of stillness. Closer in drifts Europa, its gleaming crust a thin veil of ice concealing a global ocean of liquid water, one of the most tantalizing prospects for life beyond Earth. And then, perilously near the swirling clouds of Jupiter itself, orbits Io, just over 350,000 kilometers from the planet's upper atmosphere. Roughly the size of our own moon, yet denser, heavier, forged almost entirely from silicate rock and iron. What sets Io apart is its utter lack of water, the driest known body in the entire solar system, even surpassing sun-scorched Mercury in its aridity. No vast oceans, no hidden ice layers, just rock upon rock, metal at its core. Yet this barren world burns with an inner fire that defies the freezing dark. It hosts more active volcanoes than anywhere else we know, hundreds erupting continuously, up to 400 centers of molten rage dotting its surface. This volcanic dominance was first unveiled in 1979, when a pioneering probe skimmed past Jupiter and captured unmistakable signs. Towering plumes arcing hundreds of kilometers into space, lava fountains painting the landscape in fresh scars, even through primitive cameras from tens of thousands of kilometers away. These infernal displays clash violently with the moon's frigid reality. Away from active zones, surface temperatures plummet to minus 130 degrees Celsius or lower. The sun, a distant pinprick, offering no meaningful warmth. So where does this apocalyptic heat originate? The answer lies in Io's treacherous orbital position, caught in a gravitational vise that no world should endure. Jupiter's immense mass tugs relentlessly, stretching the moon's rocky body, while the other Galilean moons, Europa, Ganymede, and distant Callisto, pull from opposing directions through subtle but persistent resonance. This orbital lock forces Io into an elliptical path rather than a perfect circle. At closest approach, it hurtles nearer to Jupiter. At farthest, it pulls away. Every 42 hours, this cycle repeats, subjecting the moon to alternating gravitational crush and release. Imagine squeezing and flexing a ball of solid rock over and over. The friction alone would generate heat. On Io, this tidal flexing is magnified to extremes. The solid surface bulges upward by up to 100 meters at closest approach, distorting the entire moon into a subtle egg shape before relaxing again. This constant kneading pumps enormous energy into the interior, melting rock deep below and driving it toward the surface in explosive release. It's the same principle that raises Earth's ocean tides, but here applied to rigid stone rather than water. On our world, tides lift seas by mere meters in open ocean. On Io, The same force deforms planetary crust itself, turning gravitational torment into geothermal power. Yet Io's volcanoes bear little resemblance to Earth's familiar cones. No towering stratovolcanoes built from layered ash and lava. No subduction zones where plates grind and dive. Io lacks plate tectonics entirely. Instead, magma surges through fractures opened by tidal stress, erupting in vast floods or curtain-like fountains that can hurl material dozens of kilometers high. Above many vents, plumes of sulfur dioxide gas soar hundreds of kilometers, freezing into snow as they fall back. Sulfur dominates everything here, spewed in gaseous form, condensed into vivid deposits that paint the surface in psychedelic hues. Bright yellow patches mark fresh sulfur frost. White and pale blue indicate sulfur dioxide ice in shadowed craters. Greenish tinges arise from rare sulfur monoxide altered by radiation, and deep red signal zones where sulfur polymers form under intense heat. These eruptions don't build mountains in the traditional sense. Instead, they often collapse vast sections of crust, creating enormous caldera-like depressions filled with churning lava lakes. The most spectacular is Loki Patera, a 200-kilometer-wide basin hosting a persistent sea of molten rock. Within it floats a crusted island of cooled lava, surrounded by waves of magma that periodically overturn, releasing bursts of heat detectable even from Earth. Recent observations reveal these lakes may be capped by thin, foundering crusts, perhaps even glassy surfaces reflecting the faint sunlight, turning them into infernal mirrors amid the chaos. For decades, scientists debated the source of all this magma. Could Io harbor a global subsurface ocean of molten rock, a seething layer just beneath the crust feeding every volcano? Early data hinted at the possibility, but the latest measurements, gathered during perilously close passes by NASA's long-lived Jupiter orbiter, have settled the question with stunning clarity. Gravity mapping and thermal imaging reveal no uniform magma ocean. Instead, the interior is a thick, mostly solid mantle laced with pockets of partial melt, perhaps 10 to 20% molten in places, acting like a sponge that squeezes out magma under tidal pressure. Each major volcano appears powered by its own localized reservoir, explaining why eruptions vary so dramatically across the surface. Some vents pulse steadily. Others explode in cataclysmic bursts separated by years. This patchwork interior fuels a surface in perpetual renewal. Lava flows bury craters faster than impacts can form them, resurfacing the entire moon at a rate that erases geological history every million years or so. Yet amid this flux, strange towering structures rise, isolated mountains stabbing skyward, with no accompanying ranges. The tallest reach nearly 18 kilometers, dwarfing Everest, their flanks steep and jagged. One iconic peak, often likened to a dark spire against the yellow plains, stands as a lone sentinel. These are not volcanic cones, but tectonic thrusts, forced upward as surrounding crust collapses into emptying magma chambers or compresses under global tidal stress. Picture vast sections of surface subsiding like sinkholes, displacing rock sideways and upward in compensatory uplift. The result: sudden, violent mountain birth, alien and abrupt. It is these features that NASA's orbiting explorer has now revealed in breathtaking detail. Arriving at Jupiter years ago to study the planet's atmosphere, the mission was extended to probe the moons. In late 2023 and early 2024, it executed daring close encounters with Io, diving to within 1,500 kilometers of the surface, closer than any spacecraft in decades. Cameras and infrared instruments captured lava lakes in unprecedented resolution. Churning surfaces, bright hotspots, islands of crust drifting on molten seas. Thermal maps outlined hundreds of active sites, confirming the moon's relentless resurfacing. Then, in December 2024, during another pass, the probe witnessed something unprecedented. A volcanic hotspot in the southern hemisphere flaring with power never before recorded. Larger than Earth's Lake Superior, this outburst radiated energy equivalent to 6 times humanity's total power consumption. Its glow piercing the darkness as lava and gas erupted in a sustained cataclysm still raging months later. These findings peel back layers of mystery. They show how tidal energy concentrates in discrete chambers, how eruptions may sometimes synchronize across vast distances, hinting at deeper connections beneath the crust. They reveal frost-covered peaks in the polar regions, smooth plains glazed by sulfur, and flows that extend hundreds of kilometers from their sources. Most profoundly, they confirm Io as a world shaped not by internal decay like Earth, but by external gravitational torment, a cosmic demonstration of how orbital mechanics can ignite planetary interiors across the universe. Yet for all this revealed fury, Io remains the overlooked sibling among Jupiter's moons. Upcoming missions target the icy worlds. One European explorer bound for Ganymede, Callisto, and Europa, another dedicated to probing Europa's hidden ocean for signs of life. These prioritize water and potential biology, leaving the volcanic inferno behind. The current orbiter, its fuel dwindling after years of triumphs, may soon conclude its dance. No dedicated mission to Io looms on the horizon, not yet. Priorities shift with new data, new leadership, new technologies capable of withstanding the intense radiation and heat. Still, these latest images and measurements endure as windows into a world where gravity itself wages war on rock, where fire defies frost in eternal conflict. They remind us that the solar system harbors extremes beyond imagination, forces that sculpt beauty from violence, order from chaos. What other worlds out there, locked in similar dances around distant giants, might burn with hidden fire? How many secrets still wait in the shadows of gas giants across the galaxy? Gaze upon Io's raging surface and feel the pull of that question, the same inexorable force that keeps this moon alive. Share your thoughts on what these discoveries mean for worlds beyond our own. Join the exploration as we uncover more of the universe's deepest wonders. The journey into the unknown has only just begun.